Hello viewers, hope you all are fine and warmly welcome to you all at my official YouTube channel Chemistry Coaching by Hira. Today viewers, we will discuss a most important topic that is related to petroleum industry. The content to be discussed here will include operations and processes of petroleum industry. Viewers, you are all very well know about what is petroleum, how does it forms, what are its raw material, and you also know that petroleum products are actually the backbone of country's economy. So without wasting our time, let us move toward our topic. Petroleum industry, that is also known as oil industry or oil patch, includes the global processes of exploration, extraction, refining, transportation, and marketing of petroleum products. The largest volume of product of the industry are fuel oil and gasoline. Industry can never be run without the use of unit operation and unit process. So first of all, we should have a brief introduction about unit operation and unit process. Unit operations are actually the physical treatment steps that are required to convert the raw material into a form that is suitable to the market or suitable to form product. These includes the physical changes in the raw material. These includes the primary activity and usually reversible. Its mean the reagent does not involve chemical change in its form. Example: distillation, size reduction, pumping, filtration, flotation, classification, crushing, heat transfer, and so on. In the next slide, we will discuss the unit process involved in industry. These are one or more grouped operations in a manufacturing system that can be defined and separated from other. These involve chemical changes in the raw material. It's mean here the reagent involves chemical change. Reactants are converted into products. So products are actually the transformed form of the reactant after a chemical change. These processes are involved in secondary activities. These are usually irreversible in nature, just like combustion of wood, combustion of coal, acylation, alkylation, ammoniation, aminolysis, aromatization, carboxylation, and so on. In the previous slides, we have discussed what are the operation and process involved in a cumulative industry. But here we will specifically discuss what are the operation and processes that are involved in petroleum industry. So these are usually categorized into 5 categories. First is the separation process. Second is the petroleum conversion process. Third is the petroleum treating process. Fourth is the feedstock product handling. And fifth is the auxiliary facility. We will discuss one by one in the next slides. First is the separation process. Separation involves actually distillation. What is distillation? Distillation is the separation of soluble liquid mixture into individual components on the basis of their boiling point. So it can be of two types: atmospheric distillation unit and vacuum distillation unit in petroleum industry. In atmospheric distillation, the atmospheric pressure is 1 atm, but in vacuum distillation, the atmospheric pressure is lesser than 1 atm. It ranges to 50 to 40 mmHg. The purpose of vacuum distillation to be carried out under reduced pressure is to vaporize crude oil residues that remains unvaporized after atmospheric distillation. As we know that the boiling point of something depends upon external pressure. Whenever external pressure is reduced, boiling point also reduced, so that it can vaporize at low boiling temperature and less fuel will be consumed. Here we will discuss the flow diagram for distillation. You can see in the atmospheric distillation unit that naphtha appeared at the top and kerosene appeared at the bottom. It's mean naphtha is low boiling liquid and it appear at the top because it is more vaporizable, and kerosene has heavier weight and appear at the bottom. It is less vaporized and have high boiling point. See, same is the case for vacuum distillation unit, but the significant feature here involved is that here the atmospheric pressure is reduced, that is ranges to 15 to 40 mmHg. Petroleum conversion process, that are also called chemical conversion process. As we know that after fractional distillation of crude oil, we get 20% gasoline fraction. It has low amount and low quality. Due to its high demand, less desirable crude oil fractions are converted to gasoline by different processes that are cracking, alkylation, polymerization, isomerization, reforming. These processes produce gasoline which have high quality. High quality refers as high octane number. We will discuss in the next slide what is octane number. First step is the alkylation. Alkylation is actually the introduction of the alkyl group into a compound to change it chemically. Alkylation is important unit in refinery to upgrade light olefins and isobutane into highly valued gasoline component. Light olefins are produced mainly by catalytic cracking. So catalytic cracking is actually the breaking of high hydrocarbons having high boiling point into a low hydrocarbons having low boiling point. So alkylate is one of the best gasoline blend because of high octane rating. High octane rating means high quality. Next is the isomerization unit. This process involves the converting of straight chain hydrocarbons to branched chain to improve its octane rating. So the catalyst involved in isomerization unit is zeolite and chlorinated alumina. There is the difference between the use of these two catalysts. Zeolite catalyst requires high temperature and provide low octane boost. So it is economic in petroleum industry. But chlorinated alumina results highest octane rating. However, it has high sensitivity to feedstock because it requires pre-treatment to eliminate oxygen, water, sulfur and nitrogen from the compound or feedstock. Next is the polymerization. Polymerization unit, it is actually a unit process. Polymerization is used to combine small hydrocarbons to produce large hydrocarbons that are used to produce lubricating oil, greases and waxes. So as such, it has no role in the production of petroleum, but it has a major role in the production of oil, greases and waxes, lubrications. So polymerization process have received considerable interest in petroleum refining because of high requirement of reformulated gasoline and phasing of MTBE. The process may be attractive in two main areas, and these two areas are usually petroleum industry and petrochemical areas. Next is the reforming process. So reforming unit is actually the conversion of straight chain hydrocarbons to branched chain by rearranging the hydrocarbon structure. Isomerization and reforming are actually the same because it involves the rearrangement of the chemical structure of a compound. But the purpose and the main difference is that the gasoline that is obtained after reforming has high octane rating as compared to the gasoline that is obtained after isomerization. The purpose of reforming is to improve the octane number of the gasoline. Here we will discuss what is octane number. Octane rating means percentage by volume of isooctane in the gasoline. Here we will discuss what is cracking of petroleum. The concept I have already told you in the previous slide, that decomposition of bigger hydrocarbon molecules having higher molecular weight, high boiling point into smaller hydrocarbons having lower molecular weight and low boiling point. In this equation, we can discuss the cracking of decane. So after cracking, a decane produces pentene and pentane. Pentene is the olefin and pentane is the alkane. The boiling point of decane ranges to 174 degrees Celsius, and the boiling point of these two components that is obtained after the cracking of decane has boiling point ranges to 36 degrees Celsius. There are two types of cracking involved here. First is the thermal cracking and other is the catalytic cracking. Thermal cracking is economic because it involves the use of high fuel, and catalytic cracking it not so much economic because it requires the use of catalyst. In the next slide, we will discuss the petroleum treating process. Petroleum treating process involves that how do we treat petroleum after getting it from crude oil to get desirable petroleum products. So these includes the elimination of undesirable elements that are sulfur, nitrogen, oxygen. The steps include hydrodesulfurization, hydrotreating, chemical sweetening and acid gas removal. We will discuss these terms one by one. First is the hydrodesulfurization. Hydro means hydrogen, D means removal, sulfurization means removal of sulfur. So hydrodesulfurization is a chemical method to remove sulfur from the hydrocarbon compound that comprise petroleum product. This is usually accomplished through a catalyzed reaction with a hydrogen at high temperature and pressure. It means we use hydrogen energy to remove sulfur from the petroleum products. Sulfur content in crude oil and petroleum products. Sulfur content of crude oil can vary from 0.01% to 5% weight by weight depending on the geographical source and its origin in the petroleum. So we can say that sulfur present in crude oil and its content depend upon location to location. The sulfur containing compounds are mainly mercaptans, sulfides, disulfides, polysulfides and thiophene, and these have very bad odor. In this slide, we will discuss why we remove sulfur from the petroleum products. So there are three reasons to remove sulfur from the petroleum products. First is the corrosion. Viewers, we will very know about that. During distillation we use heat. During heating, if the sulfur content of the petrol or petroleum product or crude oil is higher, then it will result in corrosion of metallic equipment in which we do distillation. Catalytic poisoning is also done by high content of sulfur. Sulfur poisons the noble metal catalyst like platinum, rhenium in the catalytic reforming unit and catalytic cracking unit. Third is the pollution. Pollution is produced due to emission of sulfur dioxide, because we know whenever sulfur containing compound is burnt, it produces sulfur dioxide that is converted into sulfur trioxide when exposed to oxygen. So sulfur trioxide is a major culprit in atmospheric pollution because it can cause acid rain after combination with water droplets. Next is the hydrotreating process. During hydrotreating, crude oil cuts are selectively reacted with hydrogen in the presence of a catalyst at relatively high temperature and moderate pressure. The process converts undesirable aromatic olefins, nitrogen and metals and organosulfur compound into a stabilized product. Next step is the sweetening process. Sweetening is the major refinery treatment unit of gasoline that treats sulfur compounds like hydrogen sulfide, thiophene, and mercaptans to improve color, odor, and oxidation stability. Sweetening also reduces concentration of carbon dioxide. The purpose of sweetening process is to improve the color of the petroleum product, odor of the petroleum product, and oxidation stability. Oxidation stability means that the petroleum product should not be easily oxidized. Refinery gas sweetening is the process used to remove the so-called acid gases, which are hydrogen sulfide and carbon dioxide, from the refinery gas streams. Auxiliary facility. Every industry has its own auxiliary facilities in order to get its main product in desirable form. Auxiliary facility units such as steam boilers, wastewater treatment, hydrogen synthesis, sulfur recovery, flares, scrubbers, and electrostatic precipitators are necessary to provide process support and pollution control. So, in order to provide process support and pollution control, we have to fulfill some auxiliary facilities. First includes the sulfur recovery, that is refers to the conversion of hydrogen sulfide to elemental sulfur. Hydrogen sulfide is a byproduct of processing natural gas and refining high sulfur crude oils. The most common conversion method used is the Claus process. For crude oil, reducing the sulfur content in gasoline and diesel improves emission controls. The sulfur recovery process removes sulfur compound from the product and thus reduces air pollution created by fuel combustion process when the products are used. So this concept I have already told you in the previous slide. Wastewater treatment. Wastewater management. Processing of crude oil requires large volume of water. This statement can be easily understood. A large portion of which is continually recycled, but some of which is moderately or highly contaminated, that will require primary, secondary, and sometimes tertiary treatment if the contaminants are very hard in the water. The major use of water in petroleum refining is for steam generation and heat transfer. Heat transfer and steam generation are the two refining petroleum units that use the water. Large volumes are lost as cooling tower evaporation. Almost every major refining operation produces a wastewater stream that contains pollutant. There are numerous processing steps in which steam, condensate, or cooling water comes in contact with the petroleum and petroleum products. Wastewater generation points are countless lakes and spills which eventually drain into the refinery sewer system. Actually, the refinery sewer system is the collection of wastewater from different areas of the refinery. So, stormwater runoff and contaminated process area is another significant source of wastewater. Petroleum refinery wastewater varies in quantity and quality from refinery to refinery. Here is the treatment wastewater treatment that includes primary, secondary, and tertiary treatment. We can discuss here. Refinery wastewater will include the primary separation of sludge, and then secondary separation, which involves also the separation of sludge, then equalization, biological treatment, clarification, and then finally tertiary treatment. Here we will discuss some of the strategies while loading, unloading, and storage of petroleum product. So first one includes no one person other than authorized person are allowed in the loading area. Whenever we load petrol in the truck or cab, so person should be other than authorized must not be allowed in the loading area. No one is permitted in the cab of a truck while loading. And no mechanical repair work, services, checks, or cleansing of vehicle or glass shall be done on trucks, tractor, and trailers while loading. Grounding or bounding devices must be connected before loading and disconnected when finished loading. If a truck or tractor motor fails to start at the loading spot, notify supervisors immediately. Static ignition hazard must be controlled. So these are all about my lecture. I hope you will like this, subscribe and comment on this video. So thanks a lot.